Hi, in this video we're going to talk about polynomials and how to sketch them on a number plane. So far we've looked at polynomials like p of x here, and we've learned how to divide them by things such as x minus 1. But what's the good in knowing how to divide by x minus 1 into that polynomial? Well, except for being a cool party trick, if x minus 1 divides a polynomial and we work out that there is no remainder, it means that it is a factor of that polynomial. But dividing takes lots and lots of time, so we'll want to know if there is no remainder in a much quicker and easier way. And there is. It's called the remainder theorem. And if we sub in p of 1 into my polynomial and get an answer of 0, that means that x minus 1 is a factor. Why does that help us out? Well, I'm glad you didn't ask. Because we can find all the other factors and write p of x as a product of its linear factors once we know what one of the factors are, in this case, x minus 1. So if we equate each of those factors, that is x minus 1, x minus 3, and x plus 2 to 0, we can work out the roots of the equation. So what are the roots? The roots in this case are going to be 1, 3, and minus 2, and you should have learnt that in 2 unit by now. So why is this important? Why do we want to know what the roots are? Well, I'm glad you didn't ask again. The roots of a polynomial tell us where the graph cuts the x-axis, or at least touches the x-axis. When a graph cuts its x-axis, the values of y are changing between positive and negative. In this function x cubed minus 2x squared minus 5x plus 6, we have a product of its linear factors. We have x plus 2, meaning that it cuts at x minus 2. We have x minus 1, meaning that it cuts at 1. And we have x minus 3, which means that it cuts the x-axis at 3. And that just helps us to draw this function on this number plane. Now, Desmos is a great website for you to use in order to help you draw your functions. I suggest you go and have a look at it while you're trying to draw these functions and learn how to type them in, and so you can get a good visual representation of what your functions are going to look like. We're going to be using some sign diagrams because they're very useful in telling us what a function does around its roots. So I'm going to show you how to do that. In example 11, we're asked to sketch the graph of f, where f of x is x plus 1, x minus 2, and x minus 3. So I know my roots are minus 1, 2, and 3, and I draw up a number line with those numbers on it. I also put 0 on there because it's good to know where 0 is on my number line. I put my roots on my number plane just by drawing dots, and I take a look at what happens to my function before and after each of my roots. So the first thing I'm going to do is I'm going to sub in minus 2 into my function, and that's going to give me an answer of minus 20. This means that my function will start below the line to the left of minus 1. The next thing I'm going to do is I'm going to sub in 0. This will tell me what happens after x is minus 1. And I get an answer of 6. This means that it's going to be a positive number after x is minus 1. Now I'm going to sub in a number that is after 2. In this case, it's going to be 2.5. And that gives me a negative answer. The number itself isn't extremely important. It is going to be a number on our number plane, on our graph. But the fact that it's negative is important. So we start negative. That's because we got negative 20 when we subbed in x is minus 2. We cut through the x-axis at minus 1. We stay positive until we get to 2. We go down into the negatives when we get past 2. And we stay negative until we get to 3. Once we get to 3, we're going to cut over our x-axis again, and we're going to remain positive for the rest of the time. So when x is minus 1, we're below the line, we're in negatives. When x is between minus 1 and 2, we're above the line. When x is between 2 and 3, we're below the line. And when x is greater than 3, we are above the line. So how does that help us in drawing our graph? Well, let's have a look. When x is less than minus 1, you can see on my graph that I am in the negatives for my y values. So I start with y less than 0. I cross at x equals minus 1, and then I go into the positives from everywhere between minus 1 and 2. When I get past 2, I cross through 2. When I get past 2 and I'm between 2 and 3, y is again less than 0. I'm below my x-axis. I again cross the x-axis at x equals 3, and I end up in a positive direction. Because f of x is a positive cubic function, that is that its degree is 3, it means that it will start and finish in opposite directions. If it was an even function, meaning that we might have a power of 2 or a power of 4 or 6, then that will mean that it will start and finish in the same direction. So it'll either start negative and finish negative, or it'll start positive and finish positive. We'll have a look at some of those examples in a minute. Let's say we're asked to sketch this graph of f of x when f of x is 2x cubed minus x squared minus 13 minus 6. And we want to find the values of x where that function, that graph, is greater than 0. We're going to go through a few steps to do this, and it might be worthwhile to pause the video so that you can write down each of the steps that you're going to go through. The first step is to find a linear factor of f of x by using the factor theorem. That is, subbing in different values of x to work out what a factor would be. The second step is to work out what the other linear factors are by dividing your function by your first answer, your first factor. We're going to factorize our quotient, that is the answer that we get after we divide, so that we can find the product of the linear factors. That will help us get our roots, because once we have our roots we can write them down and we can draw a sign diagram to work out what happens when our function is greater than 0 and when our function is less than 0. An important step also is to find the y-intercept, and it's pretty easy to do that just by subbing in x equals 0. Lastly, we sketch the graph using all the important points that we just found, that is the 3 roots and the y-intercept. So let's have a look at the first step by finding a linear factor. What I'm going to do is I'm going to start off by subbing in x equals minus 2. Generally you start off by subbing in x is 1 and minus 1, 2 and minus 2, but to save on some of the time, my first factor is going to be x is minus 2. So when I sub in x is minus 2, I get 0. There's no remainder, meaning that it's a factor. This means that x plus 2 is a factor. My second step is to find the other linear factors now by dividing f of x by my first answer. That is, I'm going to divide f of x by x plus 2. Going through all the steps, I work out that my quotient is going to be 2x squared minus 5x minus 3. And if I multiply those two together, I will get my function. What I'm going to have to do now is I'm going to have to factorize that quotient in order to write it out as a product of linear factors. So 2x squared minus 5x minus 3 can be written as 2x plus 1 and x minus 3. And you can do that using the cross method. Now we're going to write out our roots. Because I've got my function written as a product of linear factors, it's easier to see what my roots are. My roots are going to be x is minus 2, minus a half, and 3. Now that I have my roots, I can draw a sign diagram to work out where my function is greater than 0 and less than 0. So let's have a look. I'm going to draw a number line showing minus 2, 3, and on there again is going to be minus a half. I put the dots on my number line to see where I'm going to be crossing my x-axis. And here is the line diagram by subbing in values for numbers that are less than minus 2, between minus 2 and minus a half, and between minus a half and 3, and for subbing in a number that is greater than 3. And that is going to be the general direction of what our graph is going to look like. Step 6 was to find the y-intercept. That just means sub in x equals 0, which is probably going to be the easiest step of all of them. When x is 0, what you're left with is just minus 6. And that is where our graph is going to cut the y-axis. With all this information, we have 3 roots and we have a y-intercept. We can now sketch this diagram. So here's what it's going to look like. Please note that we cut the x-axis at minus 2, minus a half, and 3, and that the y-intercept is going to be at minus 6. Now, something that you may not be able to do at this point is work out where we're going to turn. That is, at this point here, near the 5, and this point down here, which looks like minus 22. We're going to learn that a little bit later on when we do a topic called calculus. Let's talk a little bit about the shape of functions. If you have an even function, that is that the degree is going to be even, 2, 4, 6, or 8, then we're going to get something that sort of resembles a parabola. That is that it's going to start and end pointing in the same direction. If you were to have extra terms on top of x squared, then it's going to skew our parabola, or it's going to skew all our different movements in between the start and the end. But know that if you have an even power in your function, that you'll start and end in the same direction. When we have odd functions, that is when we have a degree of 3, 1, 3, 5, or 7, that we will start and finish in opposite directions. So this cubic here starts negative and finishes positive. And that rule pretty much stays true for all graphs. So let's have a look at 2 examples. Without showing too much detail, we're going to sketch these two graphs of these two polynomials. I've actually created another video for this, so why don't you give this a go before looking at the next video? That way you can see if you got it right, or at least you got the right important points. Good luck.